Alright guys, welcome to the final review for the fall. We're going to go over some notes. So this is these are textbook questions that you can do for extra practice, which I recommend doing. But the bare minimum, there's also going to be delta, right? But the bare minimum is doing this packet. And make sure you remember you get a note card. You get a sheet of paper right front and back, so use it. Think about that as we're going through this. What do you get? What do you not get? What do you want to make sure is included on that? So we're going to start off with the rules of exponents. Pretty straightforward here. This is Algebra 1 review. Up top here we're going to have x to the third, y to the sixth, because we're going to multiply them over x to the negative 1, y to the squared. And we're going to subtract the exponents with the same term. So we'll have 3 minus negative 1 is x to the fourth, 6 minus 2 is also 4, y to the fourth. Okay, here it's going to multiply. Again, x to the 6th, y to the negative 9th. To simplify that completely, we want that positive exponent, so we can move that down to the denominator. Okay? Distance and midpoints. Use formula or just plot the points. Find the distance and midpoint between 2, 5, and negative 3, 0. So it's obviously, guys, these on the left, these on the right rather, where you want to put this in your note card. Absolutely, note card this. So remember, no worked examples can go in the note card, but the rules can. So for example, you could put up here, you could put x to the a times x to the b equals x to the a plus b. That's totally fine, but you couldn't put these up here. You can put the rules, but you can't put the worked examples. Distance between 2, 5, and negative 3, 0. So let's plot it 2, 1, 2, 5, negative 3, 0. So we want the distance and the midpoint. So using our formula, we can get the distance is going to be root x, so 2 minus negative 3 squared plus 5 minus 0 squared. So this is just root 25 plus 25, so root 50. That would be the distance, and then the midpoint would just be the average of the two of the x and the y coordinates. So we would have so okay, I'm just going to label them up here. This is x2, y2, and this is x1, y1, just because this is the first x and this is the second x sequentially, right? So negative 3 plus negative 2 over 2 comma 0 plus 5 over 2. So it would be negative 2.5 comma 2.5. Sorry, this is a positive 2 here. Airball, negative 3 plus 2 is negative 1. So it's negative 1 over 2, comma 5 over 2. So it's negative 0.5, comma 2.5. And that makes sense. When I draw it, it's right here. We can plot it, and that looks like the middle. So we can just kind of verify it by sketching. Okay, got it. So this is the midpoint here, and this is the distance. Okay, you could also kind of draw your triangle and do like an a squared, b squared, c squared situation for the distance as well. Okay, point slope form. Really important to know this. Y minus y1 equals mx minus x1 all over calculus. This formula all over calculus. So to find the equation of a line that contains these 2 points, we can use this equation to make this easier. So we can say, let's call this, we can make either one of these or x1 or y1. Let's just do this. And so we're going to do y minus 3 equals sum m x minus 3. 4. X minus 4. That's our x1. Okay? And so we need to get the slope. We're missing the slope. We need to find the slope. So reminder that y2 minus y1 equals x2 minus x1. So we're going to do, I know that I just call this x1 and y1, which probably is confusing to you, but when we find slope, the y2 and x2 refer to like the x2 refers to the later x value. So my later x value is the 4, so it would be 4 minus 2 on bottom, this x minus 6, that's the later one minus the earlier one, and then on top, the later y versus the earlier y. So it's 6 over 2, which is 3. And that's our equation, okay? So write the equation out, choose a set of points, plug them in, find the slope, plug that in, done. Okay. All right, equation of the line parallel through -2 to, and parallel to this equation. So if it's parallel, it has the same slope. So the question is, well, okay, what's the slope of this? Let's see, this is 2x minus 6 equals 3y. So my slope is 2/3, right? 2/3 is my slope. Because I would divide by 3, right, like that. Okay, so my slope is 2/3. So, okay, then now it's really easy. So I'm just going to use that same equation, y minus y1 equals mx minus x1. So it's going to be y minus 2 equals my slope, 2/3, x plus 2. Okay. Same point, but now it's perpendicular. So if it's perpendicular, it's a negative reciprocal. So if my original slope is 2/3, the perpendicular slope would be -3/2. So it's the same idea though. It's going to be y minus 2 equals 2/3. No. 3 -3/2 x plus 2. Okay. Factor in quadratics. We use some pretty basic quadratics to factor. This one is a difference of squares. You know that because it's missing that middle term and the outside of the perfect square. So just x plus 3, x minus 3. This one, just two numbers that multiply to equal -6 that they add to get 5. So it's going to be x plus 6 and x minus 1. Okay, and then here, the way I solve these is I use the box method, and I say, okay, well, I know that this has got to be 2x squared. I know this is -6. I know this has to be 2x. I know this has to be x, and then fill in the rest from here. So we want two numbers that multiply to get -6. They add to get -1, but I can multiply one of those numbers by 2. So it's going to be a -2 here and a +3 here, because that'll give me 3x here, that'll give me -4x here, and that will add up to -1. So my factors would be x minus 2 and 2x plus 3. Okay, quadratic formula, you know it, put it on the formula card, -b plus or minus the square root of b squared minus 4ac over 2a. Right, your a is 3, your b is -2, your c is 5, plug them in. Right, so 2 plus minus the square root of 4 minus 4 times 3, b squared minus 4ac over 6. This looks like it's going to be an imaginary solution. -b plus or minus the square root of b squared minus 4ac. Yeah, this is going to be imaginary. But anyway, it doesn't matter. This is still the same thing. Okay. Complete the square. So when we complete the square, usually this would say like equals 0. And so you get x squared minus 4x. You move that -7 to the other side. Okay. To move 7. And what you want to do is you want to identify b over 2 squared. And this is something you can put in your notes. You want to find b over 2 squared. Okay, so what is b over 2 squared? Well, b over 2 squared is just -2 over negative 4 over 2. We're going to square it. So that's negative 4 over 2 is just negative 2. Negative 2 squared is just 4. And so whatever b over 2 squared is, we're going to add that to both sides. We're going to add a 4 here, we're going to add a 4 here. So we're going to x squared minus 4x plus 4 equals 11. Then what we do is we're able to rewrite this in perfect square form. X minus 2 squared equals 11. Then you square root both sides, and you got x minus 2 equals plus minus root 11. So x equals 2 plus minus root 11. Okay? Solving inequalities using a number line. Okay. So this is algebra 1 review. You would first you get the absolute value alone, minus 1, and then we're divided by 3, so you'd have 3 absolute value x plus 5 is greater than or equal to 6. X absolute value x plus 5 is greater than or equal to 2. This is greater than, so it's going to be great or, so it's x plus 5 is greater than or equal to 2, or x plus 5 is less than or equal to negative 2. And then we solve from here. So x is greater than or equal to negative 3, and x is less than or equal to negative 7. Okay. X squared minus 5x is less than 6. You set this equal to 0, so you get x squared minus 5x minus 6 equals 0. This is just x minus 6, x plus 1. Make your number line, put a 6, and you put a negative 1 because those are our solutions. And we test points. So you test like a 10, put a 10 in, you get positive. So that's not going to work because it's going to be all positive. You plug in a 3, you're going to get negative positive, so that is going to work because it's going to be negative, it's going to be less than. And then you plug in some negative 10, so you get negative and a negative, and it's going to be positive, so it's not going to work. It would be positive, negative, positive. So this is our region, it's going to work. So our solution is negative 1 to 6. Okay. Parent functions. You should all know all the basic functions, parent functions, and then the basic transformations. Just make sure you're familiar with all these. Like, you should know what they look like. You should know their characteristics, their domain, their range, right? Domain, range. Make sure you know all of that. Just like really briefly, like domain is all real numbers for all of these. This domain is x must be greater than or equal to 0. Here x cannot equal 0. Here x must be greater than 0. Here for tan, x cannot equal pi over 2 plus pi over 2 q. Sorry, plus pi q. Yeah. Find inverse functions algebraically. So I can make sure you know the trig functions, especially. Okay, we'll have to go over that later. So to find the inverse, you switch x and y. So here, this is really a y right here, right? So if you're going to switch them, you're going to have x equals root y minus 3 over 2, and we're going to get y alone. So you get 2x equals root y minus 3. We're going to square both sides. We're going to get 4x squared equals y minus 3. And so y equals 4x squared plus 3. Okay, composite functions. So we put a function inside a function. F of g of x means this g of x is going to go inside the f of x. So we write the root x first, and that's going to replace this x. So it's going to be root x squared times 2 is f of g of x. Okay, so that's just 2x. F over g of x just means 2x squared over root x. The domain of this would be x must be greater than 0 because this cannot be 0 and it cannot be negative. Okie piecewise functions. Piecewise functions. So this is just graphing 3 different kind of sub-functions on specific domains. So for everything x less than -2, we're going to do this. So what I recommend is just plug in a -2 into this. You're going to get a -2 plus 6 is just 4. So it's going to be at -2, it's going to be 1, 2, 3, 4, but it's going to be open because it's less than. And then what's my slope? My slope is just 1. So I'm just going to draw this sort of slope of 1 going backwards to infinity. Then we're x squared from -2 to 2, pretty easy. That will be at -2 squared is just 4. And so we can just 1 squared is 1, 0 squared, 1 squared, 2 squared is 4. So it's going to look like this. And then it's 4 from x from 2 and beyond. So it's just going to be a straight line like that. Okay. Describe a function. So this is important for calc. We have domain and range. So domain is just like all the possible x values. So are there any x values that would not work? Well, if this is 1, 2, 3, 4, 5, 6, yes. X cannot equal 6 would be the domain, and it looks like x stops here at 1, 2, 3, 4. So it's like x is greater than or equal to -4 as well. That's the domain. The range here, the lowest we go is -1, but there's no breaks on the y's. Every value is covered. So we would say y is greater than or equal to -1. Okay, intercepts, well, it's just there's 2 here, it'd be 1, 2, 3, it'd be -4, 0, and 0, 1 for the y-intercept, increasing, decreasing, so that's just when it's going up, it's increasing, so we're increasing from -4 to -3, and just open brackets is fine for these, -4, -3, and we're increasing from 1 to 3, and then we're decreasing from -3 to -2, and from -3 to infinity. Okay, and it'll be constant from -2 to 1. Okay, discontinuity. So we have a jump discontinuity at -2 and 1. We have an asymptote at x equals 3. Then we have a hole at x equals 6. Okay. Relative extrema, so that's anywhere it's a peak or a valley, like that, it's a relative extrema. So this one right here is only 1, 1, 1, 2, 3. X equals -3. Absolute extrema is like the lowest or the highest point ever. So that would be y equals -1 is the absolute minimum. And there's no absolute max because it just goes on to infinity. End behavior is like what we're approaching. So when x goes to infinity with this horizontal asymptote, so it's y is gonna approach 2. We can also say that when we approach 3, when x approaches 3 from the left, y goes to infinity, and when x approaches 3 from the right, y goes to infinity. Okay. Graph and quadratics. So it's important to know the different quadratic forms. So there's the three forms. There's standard, vertex, and factored. So the nice thing about this one is that it gives you the vertex. I'm gonna give these to you for your note card. So put this in your note card. I would have, so standard is just ax squared plus bx plus c. Then there's vertex, which is ax minus h squared plus k, where h comma k equals vertex. And then factored is ax minus p x minus q, where p and q are the roots. So here, because we know this is vertex form, vertex is going to be 5, -7, so it's going to be right here. It's positive, so it's going up. And I could plug in a 6 and a 4 just to get some other points. So plug in a 6, I'd get -5. If I plug in a 4, I'd also get -5, right? So I've got my roughly kind of what this is going to look like. Okay. And then this one, okay, you get your y-intercept from there. This is your y-intercept. That's pretty nice. And then we can plug in some other points. So we could plug in, for example, -1. -1 goes in, you're going to get 3 plus 6 plus 2. 3 plus 6 plus 2 is 11. So it's actually going off the charts here. So let's actually try a 1. 1 is going to be 1. 3 minus 6 plus 2 is actually -1. Let's try a 2. We're going to get a 12 minus 12 plus 2 is 2. There we go. So now we have a picture here. So just plug in points. Plug in points, plug in x values, look for the y-intercept and then the vertex here. Okay. Find the equation of quadratic whose vertex is -1, 1 and contains a point 3, (-2). So using vertex form, we can fill this in. So it's going to be x plus 1 squared plus 1. But it has to hit these points. So this is what we've got, y equals a this. And then we need to solve for whatever that a is. So we'd say that -2 equals a, and instead of x, 3 plus 1 squared plus 1. Oh, that's 16. That's so it's going to be -3 equals 16a plus 1. Sorry, this is already gone. So it's -3 over 16 equals a. So your answer would be y equals -3 over 16 x plus 1 squared plus 1. Okay, so you're given vertex, so you can use vertex form, and then you just need to find the a. So don't forget about these a's, a in front of the equations, because those can change. All right. All right, polynomial long division and synthetic division. So polynomial long division, we write out like this. Put the numerator inside, so 2x to the 4th minus 3x to the 3rd plus 9x squared minus 14x plus 7. I'm going to grab some more paper here. I'm going to do it here. So we're going to have inside the box 2x to the 4th minus 3x to the 3rd plus 9x squared minus 14x plus 7 and outside x squared plus 4. Okay. So you ask yourself, okay, what's the biggest term that would multiply by x squared to get 2x to the fourth? That would be 2x squared. So 2x squared, we're going to multiply. 2x squared is going to be 2x to the fourth here, and then we're going to get 8x squared, which is going to go right here. And we're actually going to have a 0 here right now. And we're going to subtract. Okay, so that's going to be 0. It's going to be negative 3x cubed. And this is going to be plus x squared. Then we ask ourselves, okay, what times x squared is negative 3x to the third? Well, that's just minus 3x. We're going to multiply that. We get minus 3x cubed minus 12x would go over here, and then we subtract all of this. This kind of can drop down to minus 14x, and then we're going to get 0, and then x squared, and then here minus 2x, and then we'll drop down to plus 7. And last thing, so it's going to be a 1, right? A 1 is the last thing I can do here, so we get x squared and then a 4 here, subtract those, we get negative 2x plus 3, sorry about that. And so this right here, this is our remainder, and then this up here is our quotient. So the way we write the final answer would be 2x squared minus 3x plus 1 plus negative 2x plus 3 over x squared plus 4. And that would be it. Okay? Synthetic, so that's the long division. This is synthetic division. Synthetic, I prefer synthetic. We can only do it with these linear factors down here, so like x plus 2x minus 2, x plus 3, etc. So you put the coefficients inside, so you put 1, 3, 1, negative 3, and 3. On the outside, we put a negative 2. And we'll drop down, the 1 drops down. 1 times negative 2 is negative 2. This is 1, negative 2, negative 1, 2, negative 1, 2, 5. So our final answer would be x to the third plus x squared minus x minus 1, and then this would be our remainder here. This would be plus 5 over x plus 2. Okay. This negative 2 comes because we set x plus 2 equal to 0. That's how it comes down. Okay. All right. Potential rational roots. Okay. The potential rational roots are all the factors of the constant term divided by all the factors of the leading coefficient. So we'd have plus minus 8, 4, 2, and 1 on top, and then denominator plus minus 3 and 1. That would be all the rational roots. So it's factors of this divided by factors of this. Factors of the constant divided by factors of the leading coefficient. Okay. Zeros polynomial. So if a degree is 4, it has 4 zeros. And it has like 3 relative max at most. And if 1 plus I is a 0, then 1 minus I, it must be a 0. Okay. That's the conjugate theorem. If you have imaginary solutions, always come in pairs. Graphing polynomials, so graphing this without a graphing calculator what we would do is list out the potential rational roots like we did above. So we'd have plus minus 6, 3, 2, and 1 divided by plus minus 2 and 1. And then we would basically try these until we get one that works. So the easiest one would be to just try like 1 and -1. And we can sometimes just eyeball it to see if it's going to work. So like 1 is not going to work. You can just sort of see if we plug in a 1 here. Well, so we're going to get 2, 9, 13. Oh no, it is going to work. My bad. Another air ball. Plug in a 1 here. You're actually going to get 2, 9, 13, and then you're still going to subtract 13. So f of 1 is 0. Which is nice. That means we're going to we know that that's going to be a 0. And because f of 1 is a 0, we can actually divide the whole, polynomial by 1, like through synthetic division. So 2, 7, 4, -7, and -6 divided by 1. We get 2, 2, 11, 15. Ooh, let me look at this again. 2, 2. Oh, this is 9. My bad. This is a 9. This is a 9. This is a 13. This is a 13. And then this is a 6, 6, 0. So we'd have 2x to the third plus 9x squared plus 13x plus 6. This didn't really help us at all because it didn't change our potential rational roots, but it did make it easier to kind of plug them in down here. So we can look at like -1, and then we can look at this one instead. So -1 is not going to help us here. Not going to work. You can look at it by plugging it in. So it's going to be -2 and 9 is 7. Oh no, -1 is going to work. Again. No, -1 should work. Because look, f of -1 means 2 times -1 plus 9 minus 13 plus 6. That's 7 minus 13 plus 6. Yep, this is going to work. This is 0. So -1 is also 0. So again, we can do synthetic division. It takes a 2, 9, 13, and 6, and just divide it by -1. And then we'll get a 2, -2, 7, -7, 6, -6, 0. So now we're down to 2x squared plus 7x plus 6. So -1 is a 0, 1 is a 0, and now we're down to here. And here we could do quadratic formula, or we could factor because we have something we can factor here, or we can solve. We don't have to plug in numbers anymore. So we would do -7 plus or minus the square root of 49 minus 4 times 2 times 6. That's 4. It's just 48 over 4. So this is just -7 plus or minus 1 over 4. So it's -2 and negative 3/2. So those are my other zeros. -2 and -3/2. Since the function is even and the leading coefficient is positive, I know it's going to be going in this direction on both sides. And then because the multiplicity of these is all 1, I know it's going to cross. So it's going to look like this. 1, 1. I'm missing a. Should be like this. Like that. So it's going to cross -3. It's going to cross negative. It's going to cross -2. It's going to cross -3/2. It's going to cross -1. And it's going to cross 1. It's going to cross all of those. Let me just re-sketch that. So again, it's going to, our zeros we found were -2, -3/2, -1 and 1. So we have -2, -3/2, -1 and 1. So it's going to come down, go through, up, like that. Okay? And why is it doing that? It's doing that because the leading coefficient is even, and the leading coefficient is positive, and the degree is even. That's why it's going to end in both ways. And because the multiplicity of each of these is 1, it's going to cross through each one. Okay, graphing rationals. So these are asymptotes. Define asymptotes. So when the bottom degree is greater than top degree, we have a horizontal asymptote at y equals 0. It needs to go straight through like this. And if we were looking to graph this, we would want to plug in some values. So we can plug in like f of 0, for example, would get us the y-intercept, which would be just 0. So it's going to go right here. We also know that 2x over x plus 2, x minus 2, we are going to have these horizontal asymptotes at -2 through here and at 2 through here. Okay. And we can sketch the remaining parts of the function as such. Okay. So what will I ask you to do? I'll ask you to find the vertical asymptotes. I'll ask you to find the horizontal asymptotes. I'll ask you to be able to find the rest. You don't have to worry about sketching it from scratch without a graphing calculator, but you do have to be able to find the horizontal asymptotes and the vertical asymptotes. If it's the same degree, the HA, you divide the leading coefficients. So this should just be 1 over 1, which is 1. So we go straight through here. And then same thing here, we want to factor top and bottom. We're going to have x plus 1, x minus 1, and then x plus 1, x plus 1 at the bottom. So we're going to have a whole at -1, but we're also going to have we're actually going to have a vertical asymptote as well at -1. And then we'll have a 0 at 1. So this will be a 0 right here. And then we're going to have a vertical asymptote at -1. If it's top heavy, this would be, let's factor this, x plus 2, x plus 1 over x plus 3. There is no HA here, no horizontal asymptote. There's going to be a vertical asymptote at -3. And then we're going to have our zeros at -2 and -1. Okay. All right. Okay, we are going to call it there for part 1. Join part 2.